Okay, hello, welcome to my channel. This is Rehandran. So, I want everyone has something to say about, has their own take about circuit analysis and network theories and everything. So, I have my own say about circuit analysis. Um, so, let's try to like solve every circuit possible. Okay, so I'm gonna start my first video with the concept of signals and systems, circuit analysis in terms of signals and systems. We know that almost every electrical circuits can be considered as systems. So what are systems? We know that systems are just interconnection between elements from which if we give input we get a certain output. That's a system which gives results. So electrical systems are specifically LTI systems, meaning LTI system. What is LTI system? LTI systems, the full form is linear time invariant systems. So LTI systems help us solve different kinds of circuit problems in electrical engineering. The concept of LTI systems. So LTI systems specifically follow the superposition principle. Superposition principle is already abided by LTI systems, which is the one of the most important principles in circuit analysis. So, if what is superposition principle, I will discuss this in later videos. But for now, superposition means that uh, uses of multiple sources in one branch or one element over one element is superposition. So what is the uh, relation between the elements under superposition principle we will discuss now. So using superposition we are able to find Kirchhoff's laws. If you see that closely, if you ponder that KVL and KCL are direct applications of superposition theorem. KVL, so we can directly say KVL and KCL are direct applications of superposition theorem. So let me demonstrate how. So this is a electric element. It may either be active or passive. I will discuss about active passive elements in later videos. So what is for this video, let us first define what is active passive. Active elements generate power and passive elements consume power. So the two elements are all LTI systems. Okay, they form an LTI system. Their interconnections form an LTI system which abides by the superposition principle, due to which we can apply KVL KCL, Kirchhoff's voltage law and Kirchhoff's current law. So let's say this is an element. How is this gonna how are we gonna apply KVL KCL which is the direct result of superposition. Now let's write this. Okay, so by superposition, if a current is going through this I1 from this point to this point, say this is the plus point to minus point, and another current is going through this I2 from minus to plus, so what will be the resultant current on this branch, on this element? Okay, so by superposition, the resultant current will be, say I1 greater than I2 is greater, so the resultant current will be in the direction of I1, and the resultant current magnitude will be I1 minus I2. This is basically KCL or KVL, you might say, the resultant value, the superposition. And for voltage we will write like this. If this is V1, this is V2, due to their superposition value, like the what is the value across the voltage terminal, across the terminal of the element of the branch or the branch, is that del V equals to V2 minus V1 is the resultant value. So this is the plus value is by convention, current convention is passive convention is regarded as higher voltage, and this is lower voltage, then this will be negative value. Obviously we can also write V1 minus V2, V1 minus V1 minus V2. This is also the superposition principle. Okay, now let's go to our next topic. So LTI systems not only abide by superposition principle, they also specifically abide by Ohm's law. What does Ohm's law tell? At constant temperature, V is proportional to I, or I proportional to V, or V equals to IR, or V equals to along for any branch at constant temperature, electrical passive or active system in limited cases abide by Ohm's law. So V equals to I, or if the branch is a resistor, then Ohm's law is this. If the branch is an inductor, then Ohm's law is L di by dt. If the branch is what capacitor, the voltage current relationship is V equals to 1 by C I dt, or I equals to C dV dt. So all of which basically follow this graph. Okay, this graph. Now for V I, or vice versa, this is Ohm's law. So these are the theorems and that LTI system abide by. They can generate linear differential equation with constant coefficient. So because LTI systems abide by Ohm's law and superposition principle, we can apply KVL KCL, and due to KVL KCL, LTI systems generate our query is electrical systems. So electrical systems which are basically LTI systems, if we model like them like LTI systems, linear modeling, which is called linear or linear approximation. So LTI systems generate linear ordinary differential equation with constant coefficient. So we which can be easily solved using the uh, formulas which are already developed. Now we are going to the circuit solving. Okay, so let us summarize. LTI system is linear time invariant system which abide by superposition, Ohm's law. Because of superposition we can apply KVL and KCL. Okay, and Ohm's law gives the linear relationship between the input and output of the branch. This is a LTI element. Okay, now we are gonna solve circuit, or you can say it's a response. What is a circuit response? Response is if you excite the circuit or if you give an input to the circuit will as a system will give an output. That's the response of the circuit or system. So linear systems give a much predictable output or response,